Yes, Assalamualaikum and very good morning. Thank you for joining us, joining me in this revision class. Okay, I just talk about the chart, the design chart that you have to use. Okay, you please select this one, which is full coverage or apa? I mean, at least you have three. You have three steel bar in every side. Okay, because sebab dalam seismic design untuk kategori DCM, yes, and DCM and DCH actually you kena ada satu di this one. Syarat dia adalah yang pertama adalah you mesti at least 3 bars in every side. Dia mesti ada 3 bar dalam satu side. Maksudnya side yang kita ada adalah side nombor 1, side nombor 2, side nombor 3 and side nombor 4. So setiap side tu dia mesti ada sekurang-kurangnya 3 bar. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay, dia ada 8. Okay. Okay, so pada side number 1, you tengok kat sini. Okay, side number 1, this one, side number 1, you ada 1, 2 dan 3. Okay, side number 2, this is side number 2, you ada 1, 2 dan 3. Side number 3, you ada 1, 2, 3. Side number 4 pun you ada 1, 2 dan 3 bar. So you need at least 3 bars. And then syarat yang kedua adalah you must arrange the bar symmetrically. Okay, you must susun dia secara symmetrical. Okay. Contohnya kat sini kita perlukan, okay, contohlah. Contohnya you kena you punya you divide kat sini, you provide katalah you provide 60-20 pun sudah cukup. Okay, you kira-kira 60-20 pun sudah cukup. Okay, let's say dia punya apa, kita perlukan 30-40 and then 60-20, let's say you check back in the table, 60-20 mungkin 3185. Okay, this is cukup. Okay, just nice. Okay, dia punya mm square lah. Okay, 60-20 sudah cukup. Actually sudah cukup, memang sudah cukup. Tapi sebagai syaratnya, okay, kalau you buat 60-20, mungkin you akan buat macam ni. Okay, this is your punya section. 60-20 mungkin you akan buat macam mana? 1, 2, 3 dan 4, and then 5 dan 6. Okay. Okay, this one is it symmetrical?
Yes, Doctor.
Yes, okay, good. This one is considered as symmetrical. Okay, syarat nombor 1 you sudah lepas. Okay, the symmetrical. But syarat nombor 2, adakah dia lepas? Is it fulfill the syarat nombor 1, adakah ia lepas? Is it fulfill the requirement number 1?
No.
No, okay, because we must provide at least 3 bars in every side. So instead of 60-20, you must increase the value up to 80-20 because the requirement from the code for for the ductility class medium, we must provide these two conditions: 3 bars in every side and arrange the bars symmetrically. Okay. Okay, let's say you you have this one. Okay. Your side. Okay, 60-20. One, 2, 3, 4, 5, 7, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Okay kata. Okay, adakah dia symmetrical?
No.
Okay, so it's not symmetrical, so please arrange it symmetrically. Atau you have you want 12 T16, let's say you have 12, so this one, okay, this one is 12. Okay, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, 12 cukup. This is symmetrical. Kalau you dapat 12 tapi you susun macam ni, you susun like this one, you dapat 12 tapi you susun 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Is that symmetrical?
No.
Okay, it's not symmetrical, so you must remove this one here. This one you remove. Okay, maybe here. Okay, so you make it like to be like this one. Okay, any question you want me to explain about the column design? Okay, because we must design for first of all. Okay, for this one, okay, saya dah jelaskan dalam video tu, kita kena for strong column and weak beam design, this is the one of the requirement for seismic design. We must provide the strong column weak beam design. So the strength of the column shall be at least 1.3 times strength of the beam. So for beam design, for exterior support, this one is your reinforcement of the beam. Okay, this is the reinforcement, top and bottom. Okay, this is the joint, interior joint. So you refer your bending moment. Your bending moment is applied moment is 280.7 kilonewton. This is the bending moment, the demand bending moment. Okay, the demand bending moment from the earthquake actions, and this is the hugging capacity, means from the top. Okay, the top we provide 1407. Okay, and then we apply here to get the capacity. This is the demand of bending moment, and then this is your supply or your capacity. Okay, so the capacity must be greater than the demand, and then this is sagging capacity from the bottom reinforcement. This is one. Okay, once again, this is your demand, and this is your supply. Okay, so the capacity of bending moment of beam at the top is 272 kilonewton per meter, and at the bottom is 144.4 kilonewton meter. So the summation, okay, the capacity of beam is the summations between the top and the bottom. So you just, okay, 27292 plus 144.4, you got the capacity of the beam, and then so you multiply by 1.3. Okay, you multiply by 1.3 to get the required, okay, the demand. Okay, the bending moment, this is the demand for column. Okay, and then at top part, okay, below the joint, the portion is 0.55 of moment, the demand. Okay, so we multiply by 0.55. Okay, we have to separate. Okay, this one. Okay, let's say this is your steel reinforcement steel bar for column. Okay, you have 3 at least. Okay, the demand, this is 0.45 of moment resistance, and then at the top bar, at the top of the joint, this is your joint. Okay, we call it as joint. is the portion is 0.55, okay, which is 55% of the moment. Okay, when we sum up, okay, this 0.55 plus 0.5 is equal to 1.0, okay, which is the whole value. So this one, okay, so this is the demand, okay, the demand for bottom part of joint. Okay, and then this is given, okay, this is with seismic static plus minus, because during the seismic actions, let's say this one, I believe this one is already in the video, so I just repeat. Okay, this one. Okay, let's say you want to design for this column. Okay, so you must know the n gravity and static. This is from gravity load case, which is load combination 3, and this is from the load seismic, which is maybe for positive and negative, because the seismic acting from here and then it will acting from here. So if the seismic load come from here, you can imagine, okay, what will happen to this column. This column will going to macam just like you tolak satu meja, you ada satu meja, this is your kaki meja tu. Okay, and then you tolak satu meja, you tolak dari sini. Okay, what will happen to this? Okay, let's say this is column A and then column B. Apa akan jadi pada, okay, this one is fixed. Apa akan jadi pada column A? Dia akan terangkat sikit, betul tak? Dia akan terangkat sikit. Okay, let's say kita ada satu lagi column kat sini. Okay, column C. Let's say this is C. Okay, this one akan sedikit, dia akan terangkat sedikit. Kalau you tolak dari sini, dia akan terangkat sikit, and then this one akan ke bawah sikit. Okay, means this one, bila dia terangkat, dia adalah negative, because it goes, it experience tensions. That's why we have a plus minus. Okay, plus minus, this one, plus and minus. Okay, bila kita you tolak dari sini, this one dia akan terangkat, and this one akan, dia makin tertekan ke bawah, so it's positive, because the compression inside the column is increased. Okay, that's why we have a plus minus value. And then so we can start our design by determining the value of D2, and then the D2 over H, and then use the chart, check the value for maximum compression, minimum compression, and then the flexure. And then we check, okay, when we determine the value of, okay, determine the reinforcement to be provided, and then we check the minimum and maximum, either it's passed or not, and then we check the distance between the bar, and then we check the clear spacing of the bar, and then we check, we recheck for the maximum compression. For the case of maximum compression, and maximum is this one, 0.6, and okay, as provided. Okay, as provided. Okay, you masukkanlah nilai as provided tadi berapa? As provided is this one, 5027. So 5027 adalah di sini, 5027. So you masukkan FYK, BH, FCK dapat 0.6 and 0.24. So you will reverse, 0.6 adalah di sini. Let's say 0.6 adalah di sini, and maximum adalah di sini. This is okay, this is 0.6 tadi kita dapat sebab kita masukkan as provided tadi. This one as provided time FIK dapat 0.6, and then it will, okay, coincide with this one, okay, as 0.24. So you kena bahagi ni lah, you kena bahagikan graf ni secara berhati-hati lah, okay. You jangan main sebarang, kadang satu you buat sini, satu you buat ni 0.24, kat sini 0.24 kat sini. So kalau you buat garis lurus nanti dia tak tepat. Okay, so and then you bawa ke bawah benda ni. Bawa ke bawah benda ni, dapat kat sini. Okay. Ini pun dia kena bagi hati-hati 0.025, 0.25 tak, 0.25, 0.21. So kat sini, dia nilai kat sini 0.203. Okay, lebih kurang lah. Okay. Okay, 0.203. So you reversekan balik equation ni, dapatkan moment capacity. Tadi kita cari adalah based on yang 0. Mana cari yes, flexion 0.20 ni adalah based on moment demand. Okay, demand. So sekarang kita nak tahu supply dia berapa, nilai supply dia berapa. So kita buat kaedah ni, kita gunakan apa, this one, tarik dari 0.6 ni, and then tarik 0.24, and then kita tarik ke bawah, dapatlah kita punya demand. And this is the line 0.20 adalah for our supply. Okay, you have to check up to this level lah. Kalau you nak buat column design, kalau ada column design, you must check up to this level. Up to checking for moment capacity. You kena check. Okay. And then you kena nyatakan nilai ni, nilai AS provided. AS provided ni berapa nilai dia, and then this moment capacity dia berapa. Okay, adakah dia lebih besar daripada yang demand. Okay. You kena check juga dia punya ni, this one you have to check untuk dapat markah penuh. Minimum, maximum, and then the distance also you have to check. Okay. And then you check dia punya shear reinforcement. This is the you derive shear reinforcement from the capacity of beam and capacity of column. You derive. This is agak kuat leceh sikit, tapi in the exam, this one, the VD will be given. Okay, to shorten your time. So the VED will be given. Okay, and then you have to check between the diameter of link, spacing. This is the requirement 1, 2, 3. You have 3 choice. So you must select the minimum value. The minimum value is 149.5. So your spacing cannot be larger than 149.5 mm. So you choose your spacing, you check the SW required. This is provided. And then you check for confinement reinforcement. This is quite complicated. This is omega WD required. Okay, must be greater than 0.08 for DCM structures. And this one is provided. So provided must be greater than the required. So you can take a look here how to increase the provided. Okay, you can increase the provided by first, apa cara dia? Dalam video saya ada share macam mana cara nak increase the omega W di provided. In case you dah propose 2T650 ni, tiba-tiba tak lepas pula provided value ni. Apa yang you kena buat untuk meningkatkan provided ni?
Reduce the spacing, increase the diameter of bar, increase the number of bar.
Good. You reduce the spacing. This everything is based on this equation, okay? This equation. So kalau you reduce the spacing, this one kecil, so this one akan jadi besar. Okay, and then second,
increase the diameter.
Okay, increase the diameter. Diameter of apa? Diameter of dBW lah kan? Okay, you increase the diameter. When you increase the diameter, means you will increase the ASVX and ASVY. Okay, bila you increase di atas, ini pun akan naik. Okay, and then the third, how to increase. Okay, this is how to increase the omega WD provided. Okay, set number 3.
Increase number.
Increase number. Okay, so you increase the number of bar. You increase the number. Okay, maybe you can retain use similar diameter, but you increase the number. But you punya calculation akan jadi quite complicated lah. So it will be easier for you to reduce the spacing. Will be easier for your calculation because once you increase your number, okay, your ASVX akan meningkat, tapi you punya nilai what to say, you punya nilai this one. Kalau tak silap, you punya nilai, okay, you increase the number. This is 299, okay. You akan increase you punya ni, you akan kacau you punya calculation pada alpha n atau alpha s. Okay, and then you must do the sketching like this one. Okay, so you must, this one also you must provide symmetrical juga. Okay. Okay, this one be careful lah. The equation of alpha u untuk beam design pun sama. Okay, T1 lesser than TC, the equation dia lain. Kalau T1 is greater than TC, the equation dia adalah 2Q0 minus 1 kalau tak silap. Okay, you check balik dalam Eurocode. Okay, in Eurocode, clause this one. Okay, you can check back. Okay, okay, you have to refer your Eurocode, the equation, because in the exam I will give you the value of T1 and I will give you the value of TC. So you have to determine which equation to use to determine the mu theta ni. Okay, you salah kat sini, bawah semua salah. Okay, any question? Sometimes you have to use 3 number of bar, 3 instead of 2. Let's say you kena gunakan 3T16, maybe 3 or maybe 4. Okay, maybe 3T6, maybe we boleh reduce sikit 100 mm center to center. Okay, you increase this one, you reduce this one, and then you check, because you have to also consider the economical factor. Okay, in order to design, you also consider the economical factor. Kalau you nak buat 3T6 50, means you rugi kat sini sebab you dah tambah steel bar and the spacing. Ini baru satu column. Kalau ada banyak column, bermaknakan banyak besi lagi yang you kena gunakan. Okay, so you kena kat situ. This one you reduce we increase the number, so dia punya detail maybe akan jadi macam ni. So this one, okay, you tambah once buat 3. Okay, can you see this one? Okay, this is main, let's say this is arah X and this is arah Y. So here is ASVX and here is your ASVX 1 and 2. Arah X ada 2 and another one 3 is here. So this is your ASVX and the vertical one shall be your ASVY 1, 2, also you provide 3, okay, to make it symmetrical. Okay, any question for this one? The confinement, the requirement of confined reinforcement, this one is quite complicated. This one quite complicated. This is the solution lah. Kalau in case you punya omega WD provided is lesser than omega WD required, so what to do? You select between these 3. Okay, any question?
Doctor?
Yes?
For the omega provided, let's say we need to redesign. So if let's say I want to increase the spacing, so do I need to redesign everything from the beginning or just can start with?
Because you want to increase the spacing?
I mean reduce the spacing.
Oh, reduce the spacing, okay. Sorry, okay, if you want to reduce the spacing, I think you just have to start from here. Okay, let's say you want to reduce. Let's say your original spacing is 2T8175 and then you want to make it 2T 2T8 100. So you start from here, you find the AS provided. What is the new AS provided? Okay, the new AS provided, and then you use the new AS provided shall be here. This is the new AS provided is similar number, right? Shall be similar lah kan? Because 2 and 2. Okay, kalau you tambah, baru you cari yang new. Okay, this one will be fixed. Kalau in case you still use 2T8 and 2T8, this one shall be fixed and this one shall be. So you just have to, your calculation should only will involve in this equation. Okay, you just have to redo this equation. In case you increase the dBW, increase the diameter, maybe you have to do all over again from, you have to check, okay, from this one. Okay, from this one, okay, design resistance. In order to D2, dBW is involved here. If you increase, okay, let's say 35 plus 8 plus 20 over 20. So it will change here, maybe it will change a bit here. But it's okay, the rest will be okay. This is just to select which chart to use. Okay. Usually in final exam, I just, if in the past year question, the question is what to do. Okay, what to do if the provided is lesser than, okay, first you have to check. Okay, you can check. This is not a secret anymore. Okay, this is semester number 6 of this subject, so you can check the final exam question. What to do? Okay, first you have to check this one. Either this condition is provided is greater than required or lesser than required. If the provided is lesser than required, if the provided is greater than required, then it's okay. But if the value of provided lesser than required, so what to do? Okay, so I just simple, so you don't have to recalculate. You just have to propose. Okay, maybe this one, or maybe this one, or maybe this one. Okay, because the mark itu sudah hujung-hujung punya soalan, maybe soalan D atau C macam tu, dia sudah jadi 1 atau 2 markah saja. So you don't have to do the calculation all over again to prove it. Okay, so you just have to give the method. Okay, let's say in the question I give you 2T8125, so you check either it's correct or not. So you don't have to give the value how much you have to reduce. You don't have to. Okay, you just mention that you can reduce the spacing. Up to what level you don't have to mention. Okay?
Okay, doctor.
Okay, next question.
Doctor, for the confinement steel, right, is there a minimum amount of confinement we should put for the number of steel?
Number of steel lah. Number of steel, you mean apa maksudnya? Selagi you kena fikir juga lah, selagi dia boleh ikat, okay, macam besi ni kan. Let's say you detailing, you kena fikirkan juga macam ni. Kalau you buat sampai 16, macam mana you nak ikat nanti? Betul tak? Kalau you kata sampai you need 7 T6. So macam mana you nak buat? 1, 2, 3, 5 masih okay. Okay, it will also depend on your number of bar. Okay. This one one complete loop lah, here. Okay. That's why kalau dekat DCM, okay, biasanya tak adalah sampai banyak sangat. So you tak perlu guna banyak sangat. You number of bar, kalau you terlalu banyak, dia akan jadi complicated. Dia akan jadi menyusahkan you punya kerja untuk construction. So you increase lah from 6, maybe you tukar pada 8 ataupun 10. Okay, and then you reduce your spacing. Jadi you ada ruang kerja yang lebih. So you can concrete this part easily lah. Okay, so by using this one, kalau you using the DCL, okay, the forces will be higher. The forces, you ingat lagi kan assignment 2 yang saya bagi, ductility class. Assignment 2 yang saya bagi 3.9 dan 1 point. Tak ingat dah. Sudah buang ke? 1.5. So you tengok dia punya ni. Okay, what will happen to the forces? Forces DCL is increased, DCM will reduce. If the forces is reduced, what will happen to your bending moment? Okay. If the forces increase, what will happen to your bending moment?
Increase.
Bending moment will increase. Okay. And what will happen to the area of steel required? This is a flexural. Flexural.
Increase.
Okay, so dia akan increase. So what will happen to area of steel provided?
Increase.
This will also increase. So yang bawah DCM macam mana? What will happen to bending moment?
Or decrease.
All decrease. Okay, good. So this is common sense. Okay. So technically, what will happen to the cost?
DCM will be lower.
Lower. Okay, this is okay. So this one, okay. Because we use our design strength is this one. Okay, this is our let's say this is our design spectra for SDT1, and then this is the type T1. Okay, this is spectra, and also this is another one. This is from, okay, let's say this is for DCM because the Q factor is 3.9. This is for DCL. Q factor is 1.5. So this one, you still remember that the FB is equal to what? The equation. Okay, the equation is SDT1 times M times this one. Okay, M is fixed. Okay, because let's say you have the similar size of section, similar size of beam, and similar size of column, and your lambda also fixed. Okay, so what change your forces is the value of your SDT1. So if you use DCL, your SDT1 will be higher here, let's say here, and then you put it here. Compared to if you use the DCM, your T1 is similar, it will be here, lower value of forces. So we can reduce the value of forces because you can check my video topic 4, okay, topic 4 part 4. I talk about the behavior factor. Why we need the behavior factor? Okay, the behavior factor and how to derive the behavior factor. You also must study that one. You must know, okay, why we need, why it comes the value of 1.5, why the value suddenly come 3.9, maybe 3.3, 3.6, and so on. Okay, what conditions you must use 3.3, what condition you must use 3.6 or 3.9. Okay, because it's the result is uneconomical. Okay, when you use okay, this one, the very high forces and very high bending moment, maybe you have to increase the size of section compared to DCM, lower size. Okay, this is higher size, and then what will happen to the amount of concrete? Okay, it will affecting the amount of concrete, also the volume of the area of formwork you have to provide, and also the steel reinforcement will increase. Okay, but however, for the, okay, for this one is for flexural reinforcement. Okay, this is for flexural reinforcement. For flexural reinforcement, DCL require higher than the DCM. However, for the shear reinforcement in column, the DCM require higher than the DCL because we have to fulfill the requirement of, fulfill the requirement of confinement reinforcement.